Hi, I'm Adrian Da Vinci. Welcome to my channel. Today, I will show you how to find the middle node of a linked list. By the end of today's conversation, you will be able to solve this problem by two different approaches. Let's get started. So our goal is to find the value at the middle node of a linked list. So here we have the structure. We have 1 which points to 2, 2 points to 3, 3 points to 4, 4 points to 5, 5 points to 6, right? So before we get started, I want to emphasize that we are dealing with a linked list, not an array and not a regular Python list. The reason why this distinction is important is because unlike an array or a regular Python list, we cannot just jump directly to the middle because we do not know the middle. Again, this is a linked list, and the only way to access the middle is to know the pointer which points to the middle, right? So that's a really important distinction because that part may not be obvious, right? So the first approach that we're going to look at today is brute force, right? And I'm going to break this down into steps. So here on the left side, we will call this method 1. And for method 1, the very first step is actually just to iterate through this structure one time. So we just go through this 1, 2, 3, 4, 5, and 6, and we count the nodes. So step 1 is count nodes, right? And let's assign these nodes. Let's call this n. So n is equal to the node count. And then step 2 is to find the midpoint. Now, one thing that we have to keep in mind as well is that it really depends on what we have. If we have an odd number of nodes, then the midpoint will be the one in the very middle. But if we have an even number of nodes, as we do in this situation, really there is no middle. So in that case, we must take a bias either for the left or for the right. In this particular case, we're going to look at the bias for the right side. So like we're going to say 4 is the middle. So in this case, we're looking for the middle node, and let's call that, and we will define that as n divided by 2. Once you pass n divided by 2, then we are at the middle. Step 3 is to iterate a second time, and then you stop after you pass m. So put iterate second time and stop after m. So in this case, we would go 1, 2, 3, and stop after 3, which is 4. To kind of make this come alive, we'll use this actual example given here and count the nodes. We get 6, and then m divided by 2 is 3, and then we stop after 3. Stopping after 3, we get 4, and as I mentioned, that is the right bias that we're taking here. So we stop after that, and then essentially we return the value at that node, which is going to be whatever that holds. So that's the first method. The next method, call this method 2, is to use related rates. So what do I mean? This one's pretty cool because this uses a relationship between different rates. What we do is we iterate with 2 different iterators. We have one iterator that skips 1. So we call this a slow iterator, skips 1 every time. And then we have another iterator that each time is skipping 2. So let's call this, give it some names. We give this fast iterator F, and then we give the slow iterator S. So what happens is, by the time F gets to the end, because it's moving twice as fast, the slow iterator will be at the middle. So that's the big picture. So step 1 is to create a slow iterator. Step 2, create a fast iterator. And to be specific, when I say slow iterator, we are skipping one item each time. So I'll just put +1. And then with a fast iterator, we are plussing 2. And then step 3, once F, which is a fast iterator, reaches end, and you can tell that you've reached the end because that node is not pointing to anything. So once F reaches end, then return value at the slow iterator S. And that's essentially it. So these are the two different ways that we can use to find the middle node of a linked list. As far as code, you can code this in various languages. You can do this in Python, Ruby, C++. But the most important thing here is to see the big picture and understand what's being done. If you have any questions, please leave those questions in the comments. And thank you very much. Bye-bye.